So, last time we see how we can move around the players, how we have two players fighting each other, and how we can control two players by different controls, and how we can fight and do combos. In this video we will see how we can write a basic AI so that we have an opponent to fight. So, before we start, I've already made a new animation, and that animation is for blocking. It's this block, and if you go, you can create it pretty easy by yourself. You create a new clip, name it whatever you want. I want it to be named block, and just drop the sprite in the keyframes, but not in the same level as the animator, not in this sprite render, which this should be even in here. In this sprite render, okay. It's the same principle as we talked before. So after that, make the new state, find the new state inside your animator, and simply create a new parameter named blocking, and then make a transition without X time and the transition duration to be at 0 and the conditions to be blocking true, and then the same for the transition back to idle, blocking false. Now that's all, pretty much everything you need to do with the animator. And so let's go back, let's select the player, and let's create a new C# script which we will call AI character. Now I will select the player and simply drop the AI character inside. Now before we go into the AI character, I will open up player control, and I want to change some variables over here. And the variables I want to change is create a new public bool, which I'm going to call AI character, and that is because we don't want to write a new controller just for the enemies. Since we already have one controller, we just simply can have a script that decides if a player is an AI character or it's not, and then do whatever is necessary. Now I want to make the enemy public so that we can use it in our other script, and then let me see, I want also this, the jump. I think this was named jump key in the previous video. I also want this to be public, and that's it for now. We will return in a bit, or maybe yet before we go, let's make sure. So when we on start, if this is an AI character, we want to check if we don't have a get component AI character, then simply just add it. I'm not adding an AI character in any case. I'm doing it this way. I added an extra check because I want to drop the AI character script from beforehand into our game object so that we can tweak it around. But if I forgot to add it and I have it as an AI character, it will add it by itself so that we don't get errors. So let's go open up AI character, and then the first thing we know we need it will start adding some variables. Let's delete this. So the first thing of course we need is the player controls, our player controls, we will call PC. Now the second thing we will need is the player controls of our enemy. Now we want a public float with we'll name change state tolerance, and I'm going to initialize it with 3. You will see in a bit what all this stuff are. So I need another public float, which is we'll call it normal rate, and I'm going to give it something like 1. Now this normal rate is when our player, when the enemy is further away from his enemy, on how many seconds it will take before deciding a new state. We will add an internal normal timer. We'll add a new public float, which we're going to call close rate. This is on how many seconds it will decide what he will do if he is close to the enemy. And I'm going to rename internal timer. Now let's add all our variables so that we do not move back and forth. Blocking rate, it's pretty much the same. Our internal variable. So this float is AI state life, is how much time the AI has before closing its state and resetting its AI states. So I need a bool which it will help us when we have decided which state we have. This bool will help us execute that state. Now I want a bool so that I know if I am close to the enemy or not, and I need 2 more variables, and because we're going to base a lot on random values and multiplying these random values, so that we decide its state based on a percentage, and we take a random value, and when we add to that random value based on multipliers, so that we get a little bit we're not so that much random. Okay, this is straight from how RPGs do stuff. We of course need somewhere to store that random value, and I'm going to add a bool which will be checking if the enemy is blocking. We need a boolean to know if we are blocking. We need a float that it's going to be our block multiplier, and we need a boolean that help us randomize how many times he will attack, and how many times we will need an integer for number of attacks and an integer to store how many attacks he has already done. And the final variables we will need will be public float. It will be a jump rate. Let's give it something like 1. The internal jump rate, our boolean if we're jumping, and finally an internal jump time. Now this is all our variables we're going to need. Actually, not all. So, forgot some. So, we will need a public enum, which we're going to call AI states, and we're going to create a few states. This will be the close state when we are close. This will be the normal state when we are further away from our enemy, and then finally we need a reset AI, and of course we need somehow so that we can change the state we are currently in. So these are our variables. So now that we have them all, let's create a new region. Now you should probably separate which are internal and external variables. Okay, and since we have all our variables over here, let's close this so that we are pretty much more organized. So on start, the only thing we need to do is of course get our player controls. So now, before we go into update, let's start writing some our functions. Let's start with the normal state. Let's close the update for now. Let's bring this up here. So we will create a new function which will call void normal state, and when we are in this function we want to take the normal timer and add to it by time, and if the normal timer is greater than the normal rate, then we want to say initiate AI equals true and the normal timer equals 0, and that's it, the normal state. For the close state, it's going to be pretty much the same. Now we could store these functions together, these two functions, but let's just do it this way. And same as before, when the timer is over the close rate, we initiate the AI. So now we have this. We want to do a check that changes the says to us if we are close to the target or not. So we make a new void, a new function that returns a void, and we will name it check distance. So for distance we want a float, and this will be vector3.distance. we pass the transform.position, and we pass the enemy position. So if our distance is lower than the change state tolerance, then we will do a check and we will say if our AI state is not equals the AI state dot reset AI, so we are not in the process of resetting our AI, then we will change our AI state to AI state dot close state, and of course close combat equals true. Else, if again our AI state is not equals AI state dot reset AI, AI state equals AI state dot normal state. Now, if we are on close combat, we want to say, if we are not, so yes, but since we are, or maybe let's just leave this uncommented for now. We will see later why we have it as this. For now, let's just only add the combat, the close combat to equals false. So we have our check distance, we have our close state, and then we of course need to change this to have a new function which we will call states, and we will store a switch over here, and we will say switch AI state case AI state dot close state, and we make a break, case AI state dot normal state, and new break, and case AI state dot reset AI and break. So close state, we will pass the close state function. Normal state, we will pass the normal state, and for the reset AI we of course going to create a new function which we will call reset AI, and over here we want our AI timer, and we will add to it by time.delta-time of course, and then we will say if AI timer is greater than AI state life, then we want to say initiate AI equals false, and then we will pass this over here. Now let's add a function that will help us move our character. So I'm going to create a new void, and I will say movement. So we want to move our character, or maybe let's just say it like this: if our enemy dot position dot x is lower than transform dot position dot x, then we want to manipulate the horizontal, which we forgot to make it public over here. So let's go to player controls and take our horizontal value and take our vertical value and make it also public. But this even though we are having public, and even though we will be changing the values from AI character, you will see that over here we override their values based on the input. But since we have this will be an AI character, we can't just have them move around, otherwise they will move by pressing the keys. So we will say if not AI character, and only then you will move, not this AI character, we want this, the boolean. So, and only then they will move by the input. Let's go back, and then we will say where we are in our movement function. We will say if our enemies position, the x of our enemies is lower than our transpose dot x, then what we will do, we will pass on our horizontal value, we will pass the -1, else our horizontal value will be 1. Okay, so now that we have our one function to see, let's create our AI agent. AI agent. So we will say if initiate AI then the first thing we need to do is, of course, say that we want to start the process of resetting our AI. And for now, the only thing we're going to do is pass the movement function. Okay, so let's go inside update and let's start dropping our functions. Now, before we start dropping our functions though, let's say if we do not have an enemy, our player control enemy, it's not populated, then and only then take the component from our stored enemy and store it. Now we do not drop this inside start because of the way we find our character. In here we find the enemy, it might return null, so it might never initialize, so we give it a little time. So for every frame we do not have an enemy over here, we simply take the stored from player control. Okay, so let's start dropping our variables. First we need to check the distance, then we need to check our states, and then finally our AI agent. So Ctrl S to save, and let's jump into Unity. I'm going to select one of my characters and I'm going to tick AI character, and now in theory this should probably work without any problems. Now I've also added some walls over here so that our characters do not fall from the ground. So let's see what will happen if I hit play. So you see that for every, let's turn this into debug mode, and then let's hit play and pause immediately. So into our AI control over here, you will see that in every frame we add to the normal timer, and when this normal timer is over 1, it takes the initiate AI. So this initiate AI goes into our player control script and passes the horizontal to be -1. Of course, now this it will only move towards our character, and it will actually not even update when we jump over here. So let's go back and let's add some more interesting stuff. Let's start with our check distance, or maybe not. Let's add a state that will make our agent start attacking. So let me close this a little bit. Over here, let's say attack. And then the first thing we want to take is, if we haven't got a random value, of course this will be immediately true, then take our store random, and we can do something like random dot range 0 to 101. This will return a value between 1 and 100. But since we are going to be calling this a lot, let's not use it this way. Let's go back down and say, let's create not a void, let's create a float, and we will name this return random, and we're going to create a new float inside, which will then name it return value, and we will do random.range 0 and 101, and then we will return that return value. So every time we need to call this, instead of using a random.range every time, let's just say we will call the return random, and we will be done. So we have a store, we have a random variable, so that we have a percentage of what our AI agent can decide to do. So we will say if our store random is lower than 75, and you will see later why 75, then if we haven't take a random number for our attacks, how many attacks we will do, we will create a new number of attacks, and this, I want this to be cast as an integer, and we will return a random.range between 1 and let's say 4. Now I want 1 because I want him to attack at least 1 time. Okay, so then randomized attacks will of course be true, and then if our current number of attacks is lower than the number of attacks, then we will create a new integer with our attack number, because we have we do not have only one attack. And actually let's go back into our variables. As you remember, we did our attacks by having an array of booleans that triggered attacks and closed them, but I want to access them from the other script, so I'm going to also make this array public. Okay, so over here we want to take a random range between 0, and we also want to take the length. We will take the length so that every time we add a new attack, we don't have to add to come here and change this also. It will take it automatically. So we will say choose an attack, randomly choose an attack from inside our array of attacks, and then attack. And of course we need to increment the current number of attacks so that we do not attack all the time. So now that we have a movement and an attack, let's go back into our AI agent and let's start doing the same thing. So AI state, oops, we've added this. So instead of straight going into movement, we'll keep doing the same, and we will say if dot random, then store random, return random. Now of course you can differentiate between these floats, because there is a slight chance this will not be false, so that it will take this and it will decide all this by itself. But since we are doing this we could use this number for everything, for every case we have over here, so it doesn't really matter that much. But if you create different variables for this, for each case you will want to check, then you will have a little bit more randomness in each case. So decide what you want for your own game. For the purpose of this tutorial, it will have to do for me. Okay, your needs might differentiate from mine. So we want to take a random number, and then let's do a check, and we will say if a store random is lower than 50, then attack, else move. So let's save, and if we go back now, every time the normal, let's change it from the debug mode to normal state, and let's give it a normal rate of 2. So every time the normal rate reaches to the end, it will have 50% of attacking or moving. So let's hit play and let's see it in action. Now he decided to move and he keeps moving, so there's probably something we haven't added yet. And as you can see, the AI timer is always keep adding. So let's fix that, and it keeps adding because we haven't changed our AI timer. Not false, will be 0. And on our movement, we also have to, or better yet, we don't have to just yet. So let's hit play and we will see what happens now. And as you see, it decided to attack, and as you can see, it loops between the AI timer, so the normal rate will never attack. If I change this to normal rate, then it will happen once again and once again. But because we don't reset all these values, we get this this behavior. So let's go back and create our reset AI state. So the first thing we know is that we want the initiate AI to be false. We want, if we have any horizontal movement, to be 0. We want, if we have any vertical movement, to be 0 also. The AI timer we want to be 0. We want if we have a random value, this to be false. We want to do a check. So I want to do another check for the store random, and I will say if our store random is less than 50, then AI state, I want this to be the AI state dot normal state, else the AI state will be AI state dot close state. So every time our character resets to the AI, there is a 50% chance of returning to the normal state or the closed state. Now since we have though this check distance, okay, so this will actually override this in some cases. Okay, so if it's close, then it will actually just override all this, but I'm just adding them over here. So on reset AI, we still will know that we want to reset our number of attacks to 1, and we want our randomized attack to return false. And this is the reset AI. So let's jump into our movement once again, and then let's start. We don't want him to always walk towards our position, so we will say store random equals return random, and we have gotten a random number. Then if our store random is less than 90, then move closer to him, else instead of moving close to him, move to the opposite side. So there is a 90% chance that our character, that the enemy will walk towards his own enemy. Now, of course, you can manipulate these percentages by having difficulty modes and stuff like that, and it's just a simple modifier that you can add or subtract. So this is our movement function. We do not need anything else from here. And then let's go into our attack. Now for our attacks, we have set up all the stuff we need to do, but let's create another let's create an else statement over here, because if you remember, we not only have simple attacks, but we have a special attack. So we already have this as a bool, as a public boolean. Then we will say if our current number of attacks is lower than 1, then we will say special attack equals true, and our current number of attacks, we want to increment this, so it will only do a special attack once, and there is a 75% chance of the character, instead of attacking, that he will do a special attack. And this is it for the attack. And then let's see what else we need to do. Now on our AI agent over here, we will say, instead of just checking our store random, instead of being a 50% chance of attacking or moving, let's change these odds a little bit. So I will add a new float, which I'm going to call multiplier, and I'm going to initialize it with 0. So we want to also take our random value, and we will say if we're not in close combat, then our multiplier will equals plus equals 30. But if we are close into our enemy, then our multiplier will minus equals 30. So we take a random value over here. Let's say we take this returns a value of 40. The way it is right now, we will see that our store random, the 40 is lower than 50, so it will attack. So if we add a multiplier over here, that 40 now becomes, it will either become 10 or it will either become 70 or 70. So this way we manipulate the odds. So instead of having 50% chance of this of happening, then it has either, then we add to the values, and you understand, we change the percentage by adding a multiplier to our final, to our compare value. So this is about it. We have initiate the AI, and this is the AI agent. Let me quickly see. So let's see our check distance, what we have over here. And now on our check distance, if we are close to our enemy, then we also need to take a random value. Now everywhere you see a store random, you can also, instead of using the same float, you can also create new floats just for them, so that you can have a little bit more randomized patterns. And then if this is, let's say, of 60%, less than 60%, then instead of changing the state, then you will make him move. So there is 60% of moving when we are close combat. So it might hit our enemy, but it might also move back. So, and this of course will only happen when we are in close combat. We do not want to use, or not in close combat. This will happen when the player has already ended a close combat, so it's near our enemy, but the next time it will move further away than the change state tolerance, there is a chance that our enemy will follow him around, so it will close his distance. Then let me see if I forgot anything else. And I think pretty much we are done with the attacks. So let's go back to Unity, let's save of course, and then let's make them fight each other instead of these just bugs. I'm dropping the AI character over here also. I'm going to change this into normal, and I'm going to check, let's close this, we don't need it, to check the AI character. And of course, if everything works perfect, they will start fighting each other. So you will see that they already start fighting each other. Now it might seem a little bit slow, but keep in mind that you can change the rates of attacking, how much they attack. We have all our variables over here. You can change. So let's add some more stuff, because if you see right now, if a player got hit and he can still keep moving around, and we got a null reference error. Let's see why that is. Now probably one of our triggers, something just bugged out and it didn't have one collider didn't have a player collider. So let's clear that. Now let's start adding some fixes. And on our player control and inside fixed update, we want to change where we add the forces to our character. The movement forces, we want to say if we are not taking damage and if we are not blocking. Of course, we haven't made the blocking variable yet, so let's add them. And is this going to be a pretty simple? Actually, it's going to be a public bool, which we'll call blocking. And then on update animator, we will say anim.setBool blocking, and that. Now for player control is simply just add a new input get button down and change this blocking from true to false. Okay, so I'm not going to do it over here. Now we want to change also the damage script, so I want to change this. I don't want, or maybe let's just leave it as this and see if it works. But I want to also add a new parameter to our if statement, and I want to say if we are not blocking. So if we are not, if the character hasn't already taken damage and it's not blocking, then do all this. So back into our AI character, we can add now a new function, and we will say blocking and then if our player is taking a damage and we did not have a random value, then store random, return random, got random equals true, and then if store random is less than 50, so every time our character takes damage, it will be a 50% chance of him either blocking or taking the damage. Now of course we don't need to add if he has to take damage, but we have to add if he's not. So, and of course if he's blocking, then we take our block timer and increment that, and our block timer is higher than the blocking rate, then take our blocking and turn it to false, and block timer will be 0. Let's take this and this. We do not want this to run inside our switch statement, so we're just dropping it inside our states, and these states over here are called from inside our update, so it's always running, because you don't know when the enemy is going to be attacked. You want this always to be running. And one final thing we can do is also create a new function. Let's call this jumping, because we do not want for him to only attack on the ground, and it will be the same with crouching, but I'm not going to show it. It's exactly the same, just I will just be copying and pasting code. So if our enemy is jumping, or we jump, then take our vertical and make it 1, and then turn our jump to false. Else, let's close this a bit, else our vertical equals 0. Then we need to take our jump timer and of course start incrementing by time.delta time, and then when the jump timer is greater than a jump rate, multiplied by 10, so that we do not have to add great values on our rate. So if we add 1, then the jump rate will be 10. Then if the other jump rate will be, we want to return to get a random value between 0 and 100, and then we want to create an if statement, so we have 50% chances of jumping or not. So in every 10 seconds it will have 50% chances of jumping or not. So this is the basic theory behind. Of course we need to also reset our jump timer. So this is the basic theory behind a basic AI for a DD fighting game. Well, maybe instead of the update, let's add it inside states. Let's save, and now I'm going to make the second character, I'm going to make him my player character, and you'll see why. So every time I jump, there's a 50% chance that he will jump with me. Okay, you can change this by the default settings and change the parameters. Of course, 50% chance might mean that it's a lot, and our jump got bugged for some reason. Anyway, so let's open up the AI character once again, and let's change their variables a little bit. So if we are close, let's make it to decide what to do every 0.2 seconds, and every 0.2 seconds will also be for the second one. And on the normal rate, let's make it 1, and player normal rate on both players, and then let's let them fight it out. So this is how you do some basic AI for a DD fighting game. Let's take this gizmo out of here. Now of course it's not perfect, and you can randomize a lot their values with the way I showed you, but this is a pretty good base, so you can start adding this stuff. Now normally you will see that in most games they normally perfect the AI, so every time you move he moves, and every time you attack he attacks, and then start giving faults to the AI state. So the basic theory is behind it is, if you are getting attack, run a percentage with multipliers and see if you are going to get hit, or you are going to get blocked or dodge it. And this is how AI works mostly in general. Now of course there are a lot of more examples, but this is also pretty good. So, and of course, don't forget that there is a 75% chances of them doing a special attack. So, that was it for today. Thanks for watching. Don't forget to like and subscribe. You can support me on patreon.com/C#accent, where with $5 or more you can get an access to a Google folder where I drop all my scripts, and I also add some notes and some guidelines inside them, which I sometimes forget to mention on the videos. And you also support me on creating more videos and cool stuff like this. Now, probably either this week or the next week, I'm going to start a new series. I'm not going to tell you what it is. I'm going to keep you at a tease. So, I'll see you next week, and I'll see you next time. Bye bye.